So we have this question. Find the electric field intensity due to a thin ring. Electric field due to a thin ring at an axial point. Okay. So I have to find out the electric field intensity due to this thin ring at an axial point. This point is, say, at a distance of x from the center. And the radius of the sphere is also given. Radius of the sphere is small letter a. Radius of the sphere is small letter a. Okay. Radius of the sphere is small letter a. And what I'm going to do is I'll take a small element on this ring at the top. I'll take a small element. Okay. Small piece on this ring. And the length of the ring is called dl. What is lambda's equation? Linear charge density. This can be considered as a linear charge distribution, because if you break it open, you will get a straight line, right? Just imagine you're breaking this ring and you're stretching it. You will get a straight line, right? So this is called a linear charge distribution. Okay. So I took a small element on top of it, a small segment from it, and it is called dl. What is lambda? Lambda is total charge divided by total length. Lambda is basically Q divided by L. It is called linear charge density. But since I've taken a small segment there, I better put dQ divided by dl. So if I cross multiply, what do I get? dQ is equal to lambda into dl. Okay. Imagine the ring carries positive charges all over it. Positive charges. Okay. Positive charges all over it. Right. Then what? Now tell me what happens if I put a +1 coulomb here. Why should I put a +1 coulomb? That is a standard technique to find electric field intensity at a point. Okay. So imagine I put a +1 coulomb there. Tell me what's happening. This segment, the plus on this segment will repel this plus in this direction. Okay. And that is called dE, small electric field intensity. Why do we call it small intensity? Because this intensity is created by a small element. Look at that. It is created by a small element. Okay. So it is actually what? It is the very small electric field intensity created by a very small element. I can call it dE. This very small segment on top creates a very small electric field intensity there. All right. Now that dE may be split up into two. Every vector can be resolved into two components, one like that and one like this. Okay. And let us look at the angles. If I call this angle by the name theta, this is also theta. Why? Because they are vertically opposite angles. And if this is theta, the component close to theta is dE cos theta. The component close to theta is, I can call it dE cos theta. And the away component can be called dE sin theta. Okay. And if this is A, this is x, according to Pythagoras theorem, this will be root of x square plus a square. Hypotenuse is equal to root of base square plus altitude square. Now that's all about the first part. Now what I'll do is I'll take a diametrically opposite element. Diametrically opposite element means at the other end of the diameter. This is the diameter, right? Diameter. At the opposite end of the diameter, I'll take another element, similar element. Okay, another similar element. See this? Similar element like this, which will create an electric field same as the previous one. In this direction. I can call it also by the name dE. That is also small electric field created by small element. which also may be resolved into two components, one this way, right, another one this way, another one this way. Okay. So tell me, if this angle is theta, by symmetry, this angle is also theta. If this is theta, diametrically opposite angle is theta. Then you can resolve this dE into dE cos theta and dE sin theta. Okay. Now what? If you take the whole ring, you'll have too many elements on the ring. Look at this, not these two alone. You can put a ring here, element here, another one here, another one here, here. All along the ring, you can put small elements, right? Okay. So you basically took two elements only, and then you're going to find it for the whole ring. How can you do that? Just by integrating. So if you want to get the total electric field, you just have to integrate this electric field. And before that, the components, look at the components. dE sin theta and dE sin theta being in opposite directions will cancel out. How about dE cos theta and dE cos theta? They'll add up, right? They are in the same directions. So they'll add up. How many of them? Too many of them. Because all along the conductor, all along the ring, I can put small elements like this, small elements like this. Okay. So in order to find the net electric field, I need to integrate this. Integrate what? Integrate dE cos theta. I don't have to bother about dE sin theta because sin components are already cancelled out, right? So that is equal to, what is this? Integral of, what is dE? dE is actually the small electric field. Small electric field, right? Small electric field is given by K into dQ divided by R square. All right, K into dQ. KQ by R square. Electric field is given by KQ by R square. KQ by R square. Okay, but here the charge is very small because it's a small element. I call the charge dQ. So this is electric field's equation. Look at this. Electric field is given by 1 by 4 pi epsilon naught into Q by R square. But I put a small d here because the charge is very small. So the electric field is also very small. So that is equal to K into, this is lambda dl. If you remember what I wrote in the beginning. Do you remember what I wrote? Lambda was written as dq divided by dl when we started off, right? And if you cross multiply, you get what? dq will be lambda times dl divided by r square. I can put it back to this. Electric field is what? K lambda dl divided by r square into cos theta. So last step, K comes out of integration. It's a constant. Lambda is constant. Even cos theta is constant divided by r square into integral dl. That is equal to K lambda. What is integral dl? Integral dl means dl, 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 dl. All dls are added up. That will give you the total length. Total length is called 2 pi a. The radius is a here, right? Circumference of the circle. If I integrate the small element, I'm getting the total length. Total length is 2 pi a divided by r square into, what is cos theta? Cos theta from this triangle. Adjacent side, cos theta is, this is theta. Cos theta from the triangle is adjacent side, that is x by hypotenuse. Hypotenuse is my r. Okay, because distance from the element to the point. Distance from the element to the point is called r. So finally we have K 2 pi lambda ax divided by r cube. I can substitute for all these values if I want. K, I'll keep K as such, or I'll write 2 pi first. 2 pi k lambda A x divided by, did we make any mistakes? No. R cube. What is R cube? R is x square plus a square the whole raised to 1 by 2, right? R is what? R is x square plus a square the whole raised to 1 by 2. So R cube will be what? X square plus a square the whole raised to 1 by 2 the whole cube. That will be 3 by 2. So x square plus a square the whole raised to 3 by 2. That will be the final answer. Understood this?